In this video, we'll learn about function calling using APIs. While we'll focus on using the Anthropic API with the Claude 3.5 model, these principles work similarly with newer models since the implementation is model agnostic. We'll keep this tutorial accessible by using a bash script and terminal commands, making it language agnostic so you can later adapt it to any programming language or SDK you prefer. Let's start by going to the Anthropic homepage where we'll click to try Claude 3. We need to visit the API console and navigate to the Settings section to create an API key. It's important to note that you'll need valid billing information and a positive balance to use the API. While it's not free, the service is relatively affordable if you're making API calls yourself at a low volume. For additional help, we should visit the documentation page, specifically the developer documentation. In the user guide section, we'll find the tool use guide. Tool use is Anthropic's term for function calling, which helps us get structured outputs from language model calls. However, before we dive into tool use, let's start with the basics by making a normal API call to build a good foundation. First, we'll set up an environment variable for our newly generated API key. Then we'll look at the documentation to find the basic structure of a curl command. We'll create a payload for sending a normal prompt to Claude 3 using the latest Claude 3.5 model. We'll need to set a max tokens value and include a messages block in our request. This gives us a good starting point to verify that everything is working correctly. After a couple of quick adjustments to fix any formatting issues, we'll be successfully making API calls to Anthropic using the Claude 3.5 model. Now that we have the basics working, we'll expand this into a more practical example. We'll create a script that can correct typing mistakes, typos, right from the terminal. Let's begin by taking our working API call and turning it into a proper bash script. To make things easier to read and work with, we'll open the script in a proper text editor and clean up the formatting. With our foundation in place, we need to modify the script to handle our typo correction use case. Instead of using hard-coded content, we want the script to accept input dynamically. This means we'll need to use double quotes and carefully escape quotes within our string block to make the dynamic prompt work properly. Let's test our initial script by running it with an example text file as input. You might notice that we need to re-export our API key in the terminal first. Once we do that, we can see that Claude 3.5 is already identifying misspelled words in its response, even though we haven't specifically asked it to look for typos yet. However, we want this to work as a proper function or bash script input, which means we need more structure than the default free text response that Claude 3.5 provides. This is where function calling tools become essential. We need to set up several components, starting with specifying the name of our custom tool, in this case, a tool for getting typo replacements. Next, we need to define the input schema, which tells the API exactly what format we want for the responses. We'll create this using JSON schema notation, defining an array called pairs that will contain both the typo and its correct replacement value. In our tool specification, we include three main elements: the tool's name, a description of what it does, and the exact format of data we want Claude 3.5 to return. While we could add more detailed descriptions for each value and specify which fields are required, our simple version should work fine for this demonstration. One crucial final piece is specifying the tool choice, which ensures Claude 3.5 uses our defined tool format every time we make a call. Let's test our enhanced function by running the script against our example text file again. The results look promising. Our bash tool now receives properly structured typo pairs. Looking at the output, we can see it successfully identified both typos in our file, a misspelling of file, and incorrect version of typos. The final step is to make our script automatically update the file with the correct spellings. While we won't spend too much time on this aspect since it's not the main focus of our tutorial, we can accomplish this using a JSON parser combined with the sed command for making inline replacements of the typos. When we run this enhanced version, we can see our typos being corrected in real time. To improve the user experience, we can add the bash s flag to our script to eliminate the download update message. We can also make the whole process more elegant by moving our script to a dedicated script directory. After making the script executable and adding its directory to our system's executable paths, using our typo correction becomes as simple as running the spell check command. Now we can perform on-the-fly typo corrections with confidence, knowing that Claude 3.5 will provide exactly the structured format we need through this function calling approach. If you'd like to support the channel, consider starting a free trial of our new design tool, which is linked in the description, and let us know what you think. We'll include all the code and diagram files in the description as well. Thank you very much for watching to the end, and please enjoy responsibly.